Bismillahirrahmanirrahim. This video gives solution to numerical problems from 5 to 8, unit number 13, Electrostatics, Physics 10, National Book Foundation. Problem 5. 90 joules of work is done to move 2 coulomb charge between 2 points having potential difference. Point at lower potential has electric potential of 13 volt. Find the electric potential of the other point. Let us name the point at lower potential as A and the point at higher potential as B. Now the given data is potential lower at point A is equal to VA is equal to 13 volt. Work done in moving the charge is W from A to B is equal to 90 joules. Total charge moved is Q is equal to 2 coulombs. Now to find the electric potential VB at point of higher potential B, use the formula delta V is equal to VB minus VA equal to work done from A to B divided by Q. Now the solution says substitute VA equal to 13 volt, work done from A to B as 90 joules and Q is equal to 2 coulomb in the formula VB minus VA equal to work done from A to B divided by Q. Now VB minus 13 is equal to 90 over 2. Solve this 90 over 2 to return in 45 here. Now move 13 to the other side to calculate VB. Returns in VB is equal to 45 plus 13. That is equal to 58 volts. So the electric potential of the other point is 58 volts. Problem 6. Two capacitors of 5 microfarad and 10 microfarad are connected in parallel with a 20 volt battery. Find A. Equivalent capacitance of the combination. So the given data is C1 is equal to 5 microfarad, C2 is equal to 10 microfarad, V is equal to 10 volt, connected in parallel. Now the formula for the parallel capacitance is C equivalent is equal to C1 plus C2. In order to find C equivalent, the equivalent capacitance for parallel combination can be calculated as C equivalent is equal to C1 plus C2. Substitute values for C1 is equal to 5 and C2 is equal to 10. C equivalent is equal to 5 plus 10 and that results in C equivalent is equal to 15 microfarad. So problem 6 again, and total charge stored on the combination. So given data is same as before for the same problem. The C equivalent that we calculated in the previous part is 15 microfarad. Now in order to find the total charge Q, use the formula Q is equal to C equivalent multiplied by V. And the solution is substitute values for C equivalent 15 microfarad and V is equal to 20 volts. In the formula Q is equal to 15 multiplied by 20, that results in Q is equal to 300 microcoulombs. Now, same problem 6, part C, to find charge on each capacitor. The given data is same. The formula for finding the charge is Q1 is equal to C1V and Q2 is equal to C2V. To find charge Q on each capacitor, Q1 and Q2, The solution is, remember, in parallel combination, the potential difference voltage across each capacitor is same as that of battery, meaning V is equal to 20 volt across both the capacitors. The substitute values for C1 is equal to 5 microfarad, V is equal to 20 volts, in Q1 is equal to C1V. So Q1 is equal to 5 into 20. So Q1 becomes 100 microcoulombs. Similarly, substitute values for C2 equal to 10 microfarad, V is equal to 20 volts, Q2 is equal to C2V. So Q2 is equal to 10 into 20. So Q2 returns in 200 microcoulombs. Problem 6 again, and this time it is part D, potential difference across each capacitor. Again, data is the same. To find the potential difference across each capacitor in parallel, remember, as already stated in the previous part, parallel combination, the potential difference across each capacitor is same as that of the battery, meaning V is equal to 20 volt across both the capacitors. So potential difference across each capacitor is 20 volts. Now, problem 7. Two capacitors of capacitances 3 microfarad and 6 microfarad are connected in series with a 10 volt battery. Find A, equivalent capacitance of combination. So given data, C1 is equal to 3 microfarad, C2 is equal to 6 microfarad, battery voltage V is equal to 10 volts. The capacitors are connected in series. The formula: 1 over C equivalent is equal to 1 over C1 plus 1 over C2. To find C equivalent, solution. For two capacitors connected in series, use the formula C equivalent is equal to C1 C2 divided by C1 plus C2. That's a handy formula, and it says C equivalent is equal to product over sum. Now, this is a very handy formula for calculating when there are two capacitors, and generally this formula we use if we are solving some MCQs particularly, and we are not required to give so many steps. This is a very handy formula. It helps you calculate very quickly. However, if you feel that you need to give in these steps to reach this formula, I'll explain the steps here. You have the formula 1 over C equivalent is equal to 1 over C1 plus 1 over C2. That is your desired formula. Now, the LCM is C1, C2. Taking the LCM and writing the numerator C1 plus C2 above. Now, since this value is for 1 over C equivalent, in order to find C equivalent, take the reciprocal on both sides, and that results in C equivalent is equal to C1 C2 over C1 plus C2, and that is the same thing as product of the two capacitors divided by sum of the two capacitors. This you may do on the sideline in your solution, that how did you reach this formula. Now, putting the values in this formula, C1 is equal to 3, C2 is equal to 6, 3 multiplied by 6 product divided by sum results in 18 over 9, and solving this will reducing this fraction to the lowest term results in C equivalent is equal to 2 farad. Now again, problem 7, part B, total charge stored on the combination. The given data is again the same, plus C equivalent calculated in the previous part A. Now here we need to find Q, charge stored on the combination. So Q is equal to C equivalent V. Substitute value for C equivalent is equal to 2 microfarad and V equal to 10 volts. So Q is equal to 2 multiplied by 10, that gives us 20 microcoulombs. Remember, in series, the total charge in all the capacitors is same as supplied by the battery, since there is only one path from where the charges can flow. So total charge in series combination is always same. Part C of the problem sum asks for charge on each capacitor. Given data is same, the formula to find the charge Q on each capacitor Q is equal to C equivalent V. As I stated earlier, that remember in series combination the charge in the circuit is constant throughout the circuit, means charge on each capacitor is same as that supplied by the battery. So charge on each capacitor is same as total charge calculated in the previous part, that is in part B. So answer is charge Q is equal to 20 microcoulombs. Now is the part D, to calculate potential difference across each capacitor. So given data here is same, to find the potential difference across each capacitor, the formula used is Q is equal to C1V1 and Q is equal to C2V2. We are writing only Q because Q for both the capacitor is same. From here, Q is equal to C1V1 and Q is equal to C2V2. We rearrange the formula for V1 and V2, and V1 is equal to Q over C1 and V2 is equal to Q over C2. Now to write the solution, remember in series combination the charge Q on each capacitor is same as that supplied by the battery, meaning Q is equal to 20 microcoulomb on both the capacitors. So potential difference across capacitor of capacitance C1, V1 is equal to Q over C1. That results in substitute Q is equal to 20 microcoulomb, C1 is equal to 3 microfarad, will give you V1 is equal to 20 over 3 in 6.67 volt. Potential difference across capacitor of C2, again V2 is equal to Q over C2, substitute Q is equal to 20 microcoulombs, C2 is equal to 6 microfarad, both are micros, so just writing V2 is equal to 20 over C will result in 3.33 volts. The problem 8, this is the last problem. If capacitor store 10 coulomb charge when connected with a battery of 200 volt, how much charge will be stored on it if connected with 45 volts battery? Now for solving this question, recall chapter 3 mathematics, variations. How to solve the problems, such problems in chapter 3 maths in variations. Charge given is Q is equal to 10 coulombs. Voltage is equal to 200 volts. The formula is Q is equal to CV. To find charge Q when voltage V is equal to 45 volts. Now the solution. Since in capacitors Q is directly proportional to V, using C as the constant of proportionality, Q is equal to CV. That is the formula that we are using here. And this is how we reach from here, from the proportionality of the charge to the voltage to the equation. Mark it as equation 1. Calculate C, that is C is equal to Q over V. When Q is equal to 10 and V is equal to 200 volt, then C is equal to 100 over C is equal to 10 over 200. Simplifying, it gives us 1 over 20. Now substitute C is equal to 1 over 20 in equation 1 above. This gives us Q is equal to 1 over 20 volts. Now substitute V is equal to 45 volts. So Q returns in 1 over 20 multiplied by 45, and that is equal to 2.25 coulombs.